in the data file, it will be as such printed there and read that. So D is double precision, and E format is, exponential, real negative number, and then integer, logical, X for gap on the line, and slash vertical gap, T tab space. So all these you will remember, I think you can. Then I told you that these are the different keywords of the Fortran 77, and these are also accepted in other Fortran operating system. Okay, then I told you the different arithmetic, logical, assignment, statement, unconditional goto. So we will go one by one in these and tell you. So what essentially I will be covering here, that arithmetic and logical assignments, unconditional goto, which I have not told you so far, assigned goto, computed goto, these are more variety, and then block, else if, continue is a new, pause I told you, do, undo, how we can do, read, write I told you, and call and return also. Every subroutine should end up with the function with the return, backspace, and close file, all these things. Okay, so let's see. Input, output, this was, you have to open this file. I gave you, because one of the example I gave you in my Simpson program, so follow exactly the same, or these are the brief ones, which is you can read here, and don't give format here, give a statement here like this way. So you can read and write in this way, and be very particular about the format that you are giving, FND format, and so on. Now you should know that these are non-executable functions. Like if you write program or function, subroutine, these are only written for the purpose of notation. These are not, there is no execution. So like data, giving data, there is nothing executed in this statement. Similarly, like dimension, common I will tell you today, equivalence I will tell you today, and parameter and external I will tell you today, and then integer declaration. These are double precision, you can declare complex, and data and format. These are not executable statements, means there is no execution involved. But you have to write properly these so that computer accepts it. Okay. Now let's go to the one by one, the control statement. Now the control statement, that means how you control the program, go here or there, test it, do this thing, and do loop it. So these are the logical expression, branching statement, where to go, where not to go. Also jumping after doing this, go to, assign, go to, computed, go to, looping. There are a variety of looping, do loop. Then we had also considered the subscripted variable, two-dimension array system, and then functions of program, and then all these things. Okay, so logical is clearly that, and not, I have told you how to use this variable, logical ones, and this I also logical variable and expression. Like when you write x and y, that means both should be true. X or y, one of them should be true, and these are both not true. So these are the types of logic. Okay, coming to, okay, this thing, logical if. The logical if that I told you is one of them, is like if you write if, and then some expression here. Then if this, so you have to use bracket. So if you write if here, okay. So if you write in bracket something, testing, whether greater than, less than, or whatever, you can write a complete expression here. And not only greater than, you can execute also something like 5 plus 9 into t variable in the bracket, then dot. So, but be clear that you, when you do this, you, in addition to other brackets you can have, and here the parenthesis should always be balanced. It's not 3 by parenthesis here, 2 here. So it will see that in this case, parenthesis is not balanced. So you have to go from inside to outside. So if this is correct, then it does this, executes here. Here you can give any statement, that executable statement you can give here. You can add or whatever, go to this. So all sorts of things can be done inside and outside. The only thing is when true, it execute this and then comes down. If it is false, then it comes down. Computer always runs from top to bottom. So, and it needs to know everything before it goes to any state. Like when you say any statement, be clear that everything is defined in the beginning. Most of the computer, if you have not defined, may take, like you are using ADX, but you did not define. So normally it should take 0.0, but many computer take anything available in their memory. So it's very dangerous. So always see that when you are coming top to bottom, that all the variables are defined properly. If the logical expression is true, then it executes, and then remember, then it comes down. So you have to be very careful that if it is true, then what you want to do or you don't want to do. So because it will come here, and if it is not true, even then it will come here. So you have to see that if you want to make any condition, when it is true, then it should not come here or what not. So that is very important. Many students, they forget about that. After this, it will come here. They think that, well, this is true, then it's not going to take anything below. No, the only difference is this executes and then comes down. Otherwise, it comes down automatically. It doesn't execute this. So if the, okay, now example like program odd integer. So program odd is a variable, program odd is a program, integer x, y, and rem. You see, all are real in Fortran, but since it's declared, they will be treated like IJK Only these particular variable, not starting with x. So then you can print these numbers, whatever you want to print. So since there is no variable to be print, you have simply written these in quotes, so it will print this. So if you don't have anything, just it shows that you want to print the written thing in the quotes. So then read, first it reads x, and then it defines y, x by 2, and now this type of, there are two statements written in a single line separated by semicolon. Now I am not sure that when you are doing this, then it might take or give error. If it gives error, then write y is equal to x by 2, and the next line you write rem is equal to x minus 2 star y. Remember this thing, not only maybe today you are doing using some computer it can take, and some operating system may not take it. So safer is don't use this kind of thing until you are sure, or try it. If it gives error, then you can bring it here down. No, there is no need to discuss about it. that, sir, you told me this, how to do it, now it's not taking. Well, I'm telling you that these two statements can be written on one single, but sometimes it is not possible, depending on the operating. So you can see that if it is correct, write this X is odd. So you see, checking, it is a program which checks whether it is even or odd and writes. If it is not correct, if it is not odd, then so it says that RAM, now RAM is here integer, so you can compare integer quantity. No two real quantities can be compared, like you cannot compare X if it was not integer. So if you compare, as I told you, two real quantities are never equal. So if you want to see that if two real quantities are equal, then better, like suppose we have P and Q real quantities. Now P is equal to Q, you cannot test because it will never be equal. So real quantity, you can say P minus Q is less than less than 10 to the power minus 19 something. That means if it is less than this, then that should be equal. That is what it means. So be careful about this. If you don't do this, then maybe I don't know what it is going to do. That's the problem with computer. Sometimes it will not point out error and do it on its own, which can be dangerous. You see, dangerous in the sense that sometimes your whole period is gone 2 hours and you are bothered why I'm not getting answer. So that's very annoying. Remember that. Okay. So arithmetic, if can be used like if this is this quantity or whatever is to be done here, plus, minus, whatever. But if the total quantity comes to be negative, then it goes on a, yeah, you have to give here a statement number like 10, 11, 12. If this whole quantity is 0, as I told you, it will never be 0 completely. So if these are integer, then only you can check. So 0, so you can give 100, 101, 102, or whatever you want, where you want to take it. So this will be negative, this is 0, this is positive. Means test this quantity in the bracket. If you find it's negative, so it should go on the statement number here. If you want to equal or 0 or positive 0 or equal, you can give the same statement number here. So let's see this. Like I have defined DISC B square, in that B square AX square plus BX plus C. Now B square 4AC, for example. So you are testing DISC. If it is, you don't want to take it a square root if it is negative. That means if you find this, so you can send it when. So M1 is the statement number. You see, these are the statement number here. So it goes 100, it goes 101, and now what is the difference? The only problem is that suppose it's a positive, so it comes here, no problem. But once you say that check it, and if it is 0, then it comes here and then comes here. So you have to put something that after one test is done, then where it should go. So like I can give here everywhere if it is done, whatever you want to do, and then go to, I can give a statement number 15. So continue 15, continue. So it will. So after every checking, send that, because if this is true, directly it comes here. If it's positive, directly comes here. So no problem, here onward it will proceed. But when it is true, it will come here and then comes and then. So you have to have something in between where you want to send. Okay, so block if, else if, or ladder statement. Like this, form 2. If logical expression is correct, then execute the statement written here. If it is not correct, then otherwise you do this statement. That's what you are saying. So the same if command that we have used earlier can also be like we had. So the main point is then, and you could also say, if you don't want to test, so the advantage over here is like if you use this, then it will not be going to the, it will skip the uh, thing here. So like in this case, it will come here down after one, then comes here. But if you say and if, then its only problem is that, so this is the basic statement. If checking here, then do this. And if statement finished. But if you know that if you can have other choice, then you can finish the if here and test two coil. Now here another one is like you want have three choice like in the previous one. So test it, then do executable one, then do, or if it is true, do this thing or this. The advantage of this statement if is, hold on, there is someone. Let me. Yeah. क्या किया वो जो आप क्लास बनाना है क्या लिखना, खाली साइन करना है। कोई बात। Okay, sorry, there was one person from construction division of IT. Okay, so you see here the problem is only one of them will be executed and then it finally comes after the end if. While in this case you have to have some more statement like if this is true then this will come here while you don't want these to come here. So you have to feed some statement. So that is how you should be clear about it. Okay, so like here you could test if it is less than 0, then negative, it is equal to 0, then here, and if it is greater than 0, then here. So that's what you could do for the same problem, okay? Yeah, that is what is here. The same problem can be done testing. If it is greater than 0, then roots are real. If it is less than, then the roots are complex conjugate and solutions are real and identical. So if it is minus, then this, if it is greater. So that is what I said, that you have to nest the same thing. So you can see that if you are not having clear cut, this requires 9 statements, while this one requires only one thing that you can send wherever you want. And because you could choose this statement, it jumps there somewhere. So that's not, they are not written in serial order. So M1 goes straight somewhere and finish the program. M2 goes somewhere and finish the program. So that is what it means. So this is a smart if statement, but it depends that how you want to do this. This is a lazy experiment statement. If this, do then, if this, do then, something like that. Okay. So here that is how you see we have compared to this. This is the one, the equivalent of this is here. Less than this, then go to M1, the same thing. If this is less than, if it is equal to 0, go to else, go to M3, and then. So you can see that this is what is the difference. So you can choose whatever you like. So both are equally available in the, okay. Select case, select I also, but I don't think people use select. Only few people or very standard program use select. So like here, select case, here selector is given. So like if you say case list 1, so a statement it will print. Then if list 2 cases, then this is statement. And then case default statement and select. Okay, so this is the program that you can make a case select cases. Okay, let's not. Okay, looping do loop. So, although I have told you, but here I am emphasizing in a systematic manner. Now there is a do statement and continue I did not tell you. So that is why you see in my program I have used do label, means statement number. Do up to this statement number, what you want to do. Change I is equal to initial value in the final value and in the step value. And then whatever you want to do, this will go here until it reaches the final value and this. Now this continue simply says, if you write continue and couple it with the do loop, that means take the next value. But you can use anywhere, go to something, then continue can be used. Continue simply says go ahead. That's it. So it's very safe. If you do not have any statement, you can write, bring it here and continue, it will go further on. But when it is coupled with the do loop, means go to the next value, next value, next value until final is reached here. Now it says, so this is the main do loop that so what happens that you should not use any subscripted variable here. Like you can't say if x is a dimension, do x something, or if it is now these values should be integer mostly. That is what, then it works properly. Okay, so step size is on, if it is, this one is not written with the comma, then it take automatically one difference. So you don't have to write go from 1 to 50 by each one. But if you have some step size like 1, then 3, 5 or 9, then you can do it. So these are the statements here. So this is now another do loop, do while loop. The do while loop allows a block of statements to be executed repeatedly until the specific while condition is met. You could write just here, while logical expression, if it is true, then do this thing and finish the end. So it will go until this becomes negated. That means this is not true. When this is not true, then it will not go to the do statement. As I told you, if it is true, then only it goes. So while this expression is true, do looping do, and then stop it. So like I could give here do until 100 from 1 to 5. So I can check here that if the anything I have written and increasing the value of I, so when it becomes 100, if when you can write that I equal to 100, less than 100 do is, so it will do. Otherwise, then as it becomes greater, it will go ahead. Same thing you could write do while, do this thing till that is met, that condition is met. and then undo and go. So do while loop is not a ANSI Fortran 77. Now this statement, when Fortran, if you are having a compiler Fortran 77, then this is not available there. This has come in Fortran 95 or 90. This statement. So suppose you have got a program, old program somewhere. This is 77. Don't use this do statement. Only use this do statement which it understands. While nowadays these do statement, so correct way is to use if and go to statement. That's what I. Okay, now there are just the example of this. While logical do statement here, whatever statement you want to have here, and then, as I said, this is go to statement. You write go to some point, go to some, so that can also be done. So like do looping can also be done. It means by using if statement. So label F, and then so you have to give a statement number here. So it says if this is true, then go to this statement. If this is done, when this is not true, then outside. So you can use if also for do looping. That's a smart way to do. When do loop was not known, people use this type of expression. You see, here you have to get a statement number. It says that check this is correct here, then you send it here, and when it is incorrect, then it simply goes out of it. So here is this I is 0, 100 statement. If x is greater than 0.0, then x is equal to x minus square root x, I is equal to go to 100. So it goes, after doing this, it goes to 100 again until you see I is increased here, and so also the x is increased. So if x is now this is one thing that I found is students are puzzled, like you are using do 100 I is equal to 1 to 100 by step up 2 side. It is quite likely that this variable I is not used at all. Only you need I is, so don't be nervous or don't think that it is not right. It is not necessary that this variable I should be used. Another thing I told, you cannot play with this I, you cannot modify, because you have already ordered change this from this to this until this is done. So you cannot modify, like you cannot write I is equal to after some time 4 star I. No, this is not allowed. You can use I, but you can, and even if you have not used I, it doesn't matter. It says that do the variable, so you do this way, and whether you use or not, it's not the business of computer. Simply it goes from one statement to 10 statement repeating. So it's a repetition, that's all. Computer has no need that you should use that variable. There is another do until loop. These things have developed because they become already like you are talking in English. So do until loop keeps the termination criterion at the end instead of at the beginning. Never put the until statement in the beginning. Like in this case, we have put the logical statement in the beginning. Like here, while do this thing already. Now, when you are using until, then you cannot start with this. So like do, just don't do, no statement, and until something is true. So it goes here, and suppose you are playing with x is equal to x plus 2. So you can put a check on x here. So if this is true, until this means the same thing. Like you are doing this, then if it is true, this expression, till then it should go here and here, here and here. And then when it is not met, then it goes out. So until can also be used. So depending on that, now all these things you have to remember. So what we have, do end loop replaces do continue. That's what I said, that this was the earlier one, that better use statement do 100 until 100 this point. The same thing is do variable and then end do. So either use continue or use this thing. Both are equivalent. So and now here loop 1 do and do. So there are three variety of things that are available to you. Whatever you want, you can choose. There is very interesting one like cycle statement. Means if instead of loop you can write cycle. Cycle means just go making cycle 1 time, 2 time, 3 time, 4 time. So when cycle statement is encountered inside a do loop, then one single do loop is prematurely terminated and execution continues with the next loop. So like I have said, do I 1 to 100. Okay, so this do loop finishes here. Inside the do loop, I am checking something. If expression, check this, if it is true, then do this thing. So अगर I mean अगर आप ये देखते हैं कि ये नहीं हो रहा है, or suppose you find this is you want to do loop it, so either put do loop or you just write cycle, automatically cycles it here until it becomes untrue. So this is also a smart case that you can use. So it only single statement is correct. Okay. Now there is implied do loop. As I told you in the beginning, implied do loop, you don't write do loop. Implied means automatically understood that it's a do loop. So like you say here that in the bracket I star AI comma BI comma I is equal to 1. Matlab, you can use this one when you are having I is equal to 1 comma 3. It simply means that change in this bracket I from 1 to 3. So you see, what does it mean? It will first take I is equal to 1. So it will give you A1 because I is 1, B2. And then when I becomes 2, so it gets multiplied here. So 2A2, B3. And B3 because I plus 1. So you see, you could read this way or not read, but you want to do it. So just do it. It's a same way you can have here I is equal to 4 to 6 and J is written here. So J first, this bracket is done. You know, if something is bracket, that will be the inner bracket done first, then outer brackets are done serially. So first you can see here, if you take an I4, so 4 is written, I is 4, and then this is changed. B1, 2, 3. So you see 4, B1, 2, 3. Then second one is taken. So you should not confuse that you have said this, then the first one starts here. Similarly, AI, BI, J1 to 2, I3. So you can see that this is the way it goes. The inner and outer loops are not interchangeable. You can't change it. It's defined in this way. So this is the simplest way of doing the do loop. I mean, you see, the same thing I achieved here without doing the do loop. I wanted to multiply this by 4 and then gradually like 5 or 6. So I achieved the same thing without using the do loop. That is why it is called implied do loop. You are not saying anything, but it is automatically understood that is a do loop. Okay, implied do loop is how you read these values. So you see, automatically it reads the x1 to x5. Write these things so metric can be written inner, outer. So these are the different examples you can use for implied do loop. So loop inside do loop is the same thing like do. You have three loops. So that I told you that this will be completed, this, then this will be completed, and this. So what you can see that you cannot, from inside you can jump anywhere outside. You can use go to statement, can jump side. So this is the do loop of writing also can be done in the same way. So instead of you would have implied do loop, you could, otherwise you have to write this way. So, or if you have changing three variable, you can change this. This here also you can do 100, do 200 and this, then 200 continue 300, then 300 continue 200, then 200 continue. So that's also the same thing, do loop you can do. Jumping statement, go to statement. When go to statement is used, you are not using it with if or anything. Then you just write go to 17 or go to 50. Wherever you like, you can make in a program after certain segment you don't want to, you want something to be skipped, you can do that. So a go to statement can be used to transfer control from if and do blocks, but not into them. So if you are using this in a do loop, you can use go to anywhere. If you something it does and you say after it has done go to out, but you cannot bring anything inside. Do looping cannot be modified from outside. However, do loop can be broken from inside. You are in the do loop, something you are checking that take a square root, and if quantity becomes negative, then jump out of the do loop rather than doing all of them and getting into trouble. So that is what go to is. And also sometimes for debug of the program, go to is very important. Certain you want to check something, then go to skip something and test it. Now, what is computed go to and assigned go to, that I did not tell you. So this is in the next slide. Arithmetic, if it looks, it's a repeated unconditional. Okay, that slide was not required. So here, unconditional go to. You see here, you are doing the do loop system can be done here. That if so long x is less than this, go to 10 here and do this job. And once it is done, so that means there is coupling this is a statement, but so that is why it says unconditional go to. Go to is not built in the if statement. It's a separate statement, go to 10. Go to a statement where you want, simple. Okay, there is another very smart go to known as computed go to. So here is the example. You write go to 10, 20, 30, 40. These are the statement numbers. Go to this is a. Now see, you don't have to put n is equal to. Sometimes students confuse with this. If it is 1, then go here. If it is 2, then go here. If it is 3, so it only follows the sequence that if n is 1, go on this statement. If it is 2, go on this. So it is what is written here. 10, write something. Your choice is 1. So if it is 1, first it is. Second statement, go to the sequence second. Yes. Anyone? Some question? Okay. So go. Your choice is if it is 3, then. So you can write the different statement, like if a statement negative positive can also be achieved here. 10, 20, 30, and then you can type this. So you can use this. I very much use this go to which is very good. And we, okay. So computed goes to go to versus the block. If you can see that this thing, if you can achieve with so 3-4 statement, like go to here, I am jumping out. If this is, then go to label 1, come out of it. And and if this is true, then otherwise what will happen? It will check automatically here and then here, and then comes end. So this can be achieved simply by giving label 1 and label 2 here itself. Just write 1 goes label 1, 2. So you have to select the 1, 2 here, then it go to the. So you can see it's clearly because you are making a smarter program. Assigned goto is also very interesting goto. In this case, what you do, you assign some value to an integer here in this, like n is equal to 5. And if n is equal to 5, then go to the here now statement number is important. So let's see some examples should be there. Yeah, it's better to understand. Assign 40 to n variable. That means make n is equal to 40. Go to 40. So you see if 40 is there, it will go to 40. If I say assign this to this number, then 20. So it will go to 20. So it's coupled with two statements. Assign some variable and then choose the statement here. While in computed goto, it was sequence and follows the sequence. While assign goto, it follows the statement number. You see, like it is 40, then it goes to 40 stop, emergency stop. Stop can also be used very nicely for debugging the program. If you are checking some portion, then you check this and say stop. So it will stop there. Then check some portion more and then stop. So that, okay, so pause and stop that I had not told you can be used. Stop means computer immediately stops the execution and comes out. Pause means you are asking something, just wait there. So that means sometimes you say pause there. So, and you want to feed some data, so it will pause until you give the data, then it proceeds. Common statement. Now this is most beautiful expression. Like in some cases, you want some quantity to be passed on to the subprogram or the other program. So you use common blank, then X, Y, J, and then put the same common over here. So if you write common A, B, J, then X value is taken as A and Y value is taken as B and I is taken as J. So that means you can transfer the value from here and not necessarily use the same variable. This is known as unlabeled common. But if you have written common name and variable list, so some of the common will be sent here. You can write common slash number 1 or something, then it is number 1 common. So this type of statement is used, and then you use the list. Those values normally, like you have a constant, Bohr orbit, pi and so on, so which can be, instead of typing here the same thing, you could pass on this from main program to a smaller sub program. And here, like if your list is like here, you have 3 lists. If you give simply A, B, then first 2 values are taken, third value is not taken. So but if it is a labeled common, then whatever value you have given there should be the same storage here. So this is what you have to check. Now this statement is very good to use it. I use it a lot, this, because so the most lazy person or the laziest person is the best programmer, that you don't want to write too much, but you can use. So common statements, it is not necessary to declare named common blocks and use there. These named common blocks must be exactly the same length wherever they appear. Blank common without label cannot follow the same thing that I told you. The number should be equivalence. Now this equivalence statement is not very useful nowadays. Earlier, suppose you have a dimension of any quantity A as 1500 and you want that the for B you again have a dimension 1500 storage. So what happens that A, while it's doing calculation, A 1500 is dimension, B also, so this becomes 30,100 dimension. So similarly, there are so many dimensions. So you can say that, well, while doing the calculation, use A dimension equivalent to B dimension. So after finishing the calculation, A, B dimension. So it's not that you have to declare A, B 1500, 1500. You say equivalence of A and B. So list here which dimension should be, which equivalence you are giving to the variable. Which variable are like A, B are equivalent, then it will take A 1500, B 1500. So both will be shared by itself. But remember that after doing calculation, if you want to use the same variable storage, you can do. External statement. External statement, like you are using a sub-program in a sub-program. So it doesn't know that is, so you can say externally it will require some program. Yeah, in the common, I told you, common should not mostly unlabeled common are in the have to be commons should be there in the main program, but labeled common not there. Like one set of quantities transferred from one subprogram to another subprogram can be done. Okay, so external statement, I told you, you have to declare, it's a declaration that what you are going to, then comes the compiling and program and so on. So that's all for today. If you have any question, students?
No, sir.
Okay, so now all the statements required for a perfect programming are known to you, and you can use these in your program. Now it depends how smart you are in using them, because you can make the program accordingly. Okay, so see, we will run some, I will tell you some program that you can make and run there in the next. And then both the group should join at 2 p.m. for the my lecture. That will now be for the numerical analysis. That certain program integration, differentiation, or different type of extrapolation that we will learn, so that you know that how to solve this problem, how integration can be done numerically without doing analytically, and then how to make a program. So program is a language that translates your mathematical steps to the computer, and how computer stores that I told you earlier. So that makes a complete familiarity with the computer and the language computer understands. Okay, that's all for today. Okay, any question?
Sir, so the common state is to transfer the details from one program function to the other function in the same program.
Function is not transferred, variables are transferred.
Yes, sir, the variables.
Yeah, variables you can transfer this, and yeah, that's it. Like suppose you have a pi or Bohr orbit or something or some quantity. In common, you can put also dimension. Like if you have calculated x 100 value, so you give common x 100, and the same value will be transferred all the 100 values in the subprogram. For example, like if I do Simpson program and I have all the values at different point I have evaluated, I can send in the subprogram. So that's the advantage, that if you have done some calculation in the main and you think this should be used in the subprogram, and not only in one program, put common, like the same common can be put in the one subprogram, second subprogram, third subprogram, whatever like. The only thing is where it is calculated, and from that to the where it is to be used. And you cannot change the dimension, like if it is X dimension, because it's simply storage. This is like a strip of storage transferred to this. So you cannot change. You can change the name, but suppose one is dimension, then in another subprogram that should also be dimension. So that's what. Like you don't want to use in subroutine some argument. Don't because if you list them in the argument all the time, you have to transfer. Write this. So like if I use subroutine, I always use common, because once common is done, you copy and paste there. That's it in the subprogram. While here you have to type those all the time. Okay.
Okay, sir. Thank you.
Okay. Anyone else? Okay, so you may go to your next class, and so it's meet on Wednesday.
Thank you, sir.
Okay.